All right, everybody, welcome to Chapter 3, Part 2. We are going to now discuss network technologies. If we go back a ways and we look at our objectives, this is objective number 3, which is describe the major LAN networking technologies. So that's what we're going to do now. So network technology is, of course, referring to the method that a NIC uses to access medium and send data frames. So to put that in sort of more general terms, it's how the medium is being utilized. So so in order to send frames, a frame must first be developed and then put into a format that's going to be compatible with not just the medium, but also the underlying technology that the NIC is using, that the interconnecting device is using, whether that be a switch, a hub, an access point, whatever else. So network technologies, we're going to look at some. The slide says it well. Basically, it is whether your network uses Ethernet, 802.11 wireless, token ring, or some combination of these network technologies in order to move data. Usually the most common that you'll see in LANs, which we're not delving into WAN technologies just yet. We will look at that in more detail in future chapters, but the LAN network technologies, the main ones, are going to be Ethernet and 802.11 wireless. So that's what we're going to really delve into today. So we're going to first look at Ethernet, and then we're going to jump in and really delve in to try and understand wireless. Okay, so 802.11 wireless specifically. So there's multiple types of wireless. I'll talk a little bit about Project 802. I'm not going to get in too much depth about that until Chapter 7, but I will mention it briefly. But so let's jump right in then, shall we? Okay, so of course, the LAN examples that I mentioned, Ethernet and 802.11 wireless, those are the most common. And of course, token rings, some WAN examples would be frame relay, FTDI, ATM. I'm not going to delve into those in any depth in this chapter. We will talk about those. I believe it's in either, I don't want to say for sure, I think it's Chapter 10 that we delve into WAN technologies in more depth. Okay, so the underlying technology sort of defines the frame's format and the media that is utilized. So that would be how the frame is structured, what information is included in the frame header, and what information is included in the frame trailer. We've talked about, the frames we've talked about so far have been Ethernet frames. So we're going to discuss that in a little bit more detail now. But and also the network technology would also define the type of medium that's being used. So usually the technology can change and the media can change, but the technology will generally stay the same regardless of the media. So I'll sort of get into that when we're talking about Ethernet. There's different sort of varieties and types of Ethernet. And the underlying technology changes, or the media changes slightly, and the same with 802.11 wireless. The media changes slightly, how it's utilized changes slightly, but the frame structure doesn't. So the technology is defining the frame and the media, but the frame format typically will stay the same across the board for different network technologies. So let's look at this. First of all, let's look at different types of media that are utilized by Ethernet. These are specifically the different types used by Ethernet at this point. You have the most common type, which is unshielded twisted pair, or UTP for short. You also have STP, shielded twisted pair, which we'll look at all of this stuff in more depth in the next chapter. But unshielded twisted pair consists of 4 pairs of copper wires. They're all twisted together. The twists have a purpose. It's not just arbitrary why they twist them. It actually has to do with getting the signal from point A to point B with the least amount of errors, and we'll delve into that in a little bit more detail. I'm not an electrical engineer, so I can't really explain it to you in thorough detail so that you have a very thorough understanding of why, but I can give you the general terminology. So it has to do with differential signal, number one, and what's the other term I'm trying to think about, or trying to remember. Differential signal and I'm sorry, I can't remember the terminology right off the top of my head, but differential signal as well as the twists, they're related to each other so that there's no crosstalk. It would be EMI that affects the cables or the wire pairs individually. So the whole point of the twists is to allow longer distances to be covered and at higher data rates, essentially. So you can go faster, you can put more of an electrical current into the wire at a higher rate, and it would allow it to prevent EMI from affecting wires across pairs. So that's what it has to do with. I'll describe that in more detail later, but they are twisted, and the whole point of that is for the distance of the run as well as the speed of the run. So UTP as well as STP comes in numbered categories. The most commonly used types today are Cat5e, Cat5 extended, the E is for extended, Category 5 extended, and Cat6. And we'll look at that in more detail again when we look at media in more depth next chapter. And then you have fiber optic cabling. Fiber optic cabling is literally a strand of glass. There's different types of fiber optic cabling. Again, we'll delve into that in more detail later, but it's usually very thin, like the width of a single human hair or thinner. So between 8 microns and about 62 microns. It depends on the type of fiber optic that you're using. But some fiber optic has very low tolerances for the width of the fibers. Other fiber optic has a relatively high tolerance, meaning it can go thicker or thinner. But longer distance would require less of a tolerance, so there'd be less of a tolerance for long distance fiber optic. So there's fiber optic that can do distances of like 40 kilometers, which is pretty significant. Kilometers to miles, I think it's usually about half, a little less than half of the distance. So 40 kilometers would be somewhere in the neighborhood of a little under 20 miles. So, and that's a pretty significant distance. Coaxial cable is not really ever used in LAN application anymore, though when you did daisy chains back in the day, we talked about daisy chains as being a physical bus. Coaxial cable was the type of cable that was used. It's a single copper wire with sheathing around it, meaning plastic sheathing. So I could probably draw a little picture for you. And then a braided metal mesh, and then another piece of plastic sheathing. So there's sort of a side view. This would be your copper wire coming out the front, and this would be inside of a plastic sheathing core, and then outside of that plastic sheathing on either, it's actually wrapped around the whole thing. You would have usually a steel mesh that would be like a shielding to prevent electromagnetic interference from affecting the signal. And then outside of that metal mesh, you have another coating of plastic. So you most often see that in television application as well as WAN technologies. Some WAN technologies still utilize coaxial cable, so it is still in use, but not really ever in LANs. Okay, so a quick distinguishment I want to make. Some technologies, or network technologies, can transmit signals in two ways, and I would say pretty much all LAN technologies are going to utilize baseband as their methodology for transmitting signals. Baseband, if I had to graph baseband on a chart, be something to this effect. Okay. So this would represent a 1, this would represent a 0. Okay. So over a span of time, so you have, essentially you have 0 volts. All right, make sure I'm lined up with the camera. 0 volts or 5 volts. So there's an interval of time, usually nanoseconds intervals or milliseconds intervals. And so after a given interval, if the NIC detects a 5 volt signal on the line, it will mark that down as a 1. If it detects 0 volts after an interval, it'll mark that down as a 0. So that would be a 0. Then you have a 1, 0, 0. So it's a digital signal that sends either a 1 or a 0 as a 5 volt signal or a 0 volt signal. Okay? So, and actually it can do something similar to that where it does 0 volts and negative 5 volts. Okay, so that has to do with differential signal. I'll talk about that more later, but those would be actually used in conjunction with each other. You'd have a positive 5 volts and a negative 5 volts over 2 wires in UTP, and they would both would send the signal. And that helps to alleviate the electromagnetic field. I don't really know. I'm not an electrical engineer. I don't fully have my head wrapped around it, but if you have too much of an electromagnetic field around the wires, then it causes problems. So that's where the twists come in, as well as the differential signal, which we'll talk about more later. But baseband is either the presence of voltage or the absence of voltage. Broadband, on the other hand, uses an analog signal, which an analog signal, if I were to chart it, would be something to this effect. It's a continuous range of signal. Okay, and there is no 0 volt or 5 volt. It's just different frequencies of wiring. So it's going to be, somewhere in the range of, I think it's 0 to 12 volts over analog lines. So baseband lines would be somewhere in the range of 0 to 12 volts. But you would say that between 0 and 0.0100 volts, that range represents channel 1. So you would have channels. Each channel would be a separation. So the easy application of this, and I think the understandable application of this, is with television. Television uses broadband, and so does your any ISP that you would have today would always use broadband. So they can send your phone, your TV, your internet all over a single wire, and that's because they're using broadband technology, meaning that they're dedicating channels 1 through 100, those are all your TV channels. So when you tune into channel 1 on your TV, it picks up, whatever television station is being broadcast out on channel 1. Okay, so channels 1 through 100, and then channels 100 through 200, and I'm not really sure exactly how many channels are available with coaxial cable. I believe it's somewhere in the neighborhood of a couple of thousand, but I'm not positive. So 1 to 200 might be dedicated to, this is telephone. These are telephone channels, and that would allow your telephone to come in. So when somebody makes a phone call, channel 1, or you might even have just 2 channels dedicated to that, and then 2 lines. So one channel would be line 1, one channel would be line 2, something to that effect. And then finally, they would have a number of channels also dedicated to your connection to the internet. So one coaxial cable coming in could provide a number of channels for. Oops, I better disable screen lock. I don't know if you guys saw that, but my screen just locked. Give me 1 second here, folks. Just want to make sure that doesn't happen again. All right. Okay, sorry about that. I don't know if you saw that, but my screen just went blank for a second. Anyways, so broadband, back to that. this would have to do, so as I mentioned, the ones and zeros are going to be within a certain frequency range. And so when you map out your range, I mean, this is representing a number of different channels here. But channel 1 would be, you know, and of course it would be a lot smaller than this. But channel 1 would be represented in this sort of range, okay? So when you see signal within channel 1, or let's even just say this, rather than being one channel, this is several channels dedicated to your internet connection and several frequencies, okay, dedicated to your internet connection. Each one of those frequencies is going to be some data, and each time the voltage dips below a certain number or above a certain number, it's going to actually represent a 1 or a 0 within a continuous range of values. So it's kind of hard to wrap your head around that too much. Just think about it sort of like I don't know how to equate it, but I think the best analogy is when you tune into channel 1. I mean, you can have 100 channels coming in on one coaxial cable for your TV. Think about it like that. Each channel is a different frequency. So when you change channels, you're no longer looking at channel 1's frequency, and you change to channel 2, it's going to jump to channel 2's frequency and be focused on that. Okay. So, and with newer devices like set-top boxes, that would all happen automatically. It could be pulling every channel at the same time, and then you just have one displaying up on the screen. So that's the best analogy I can give. Is it's like television, right? Television comes in on coaxial cable, and when you pick a channel, it's just going to show you what's on that channel. Then you jump to another channel, you're just looking at a different frequency. Okay? Of course I can't really get feedback since there's nobody here, but hopefully you guys all understand that. If you're not really wrapping your heads around that, I understand. Don't stress too much about that. I am going to give a study guide for this chapter that you just need to understand the definition. So know the definition of broadband is analog technologies. That's all you really need to know for now. And then baseband is digital. Okay, you should, if you can remember that, then you should be fine. Okay, so I'm actually going to stop the video here. I have to break it up, unfortunately, because I have to run. That was actually my alarm that just went off. So I'm going to stop the video here. It's about 17 minutes. We are going to continue this on. I'm going to try and have all of these up by the end of the day today before class, so that everybody can go through these. So I will see you on the next one.